A phase diagram is a plot, it's a graph of pressure versus temperature. And as we know, if you pressurize something, you can change its phase. If you increase the temperature on something, you can change its phase. So what you get encapsulated in this diagram is the solid, liquid, and gas phase of a particular piece of matter at a temperature and at a particular pressure. So we've seen this with vapor pressure, right? Increase the temperature, increase the pressure, the vapor pressure, or increase the. Well, this is the way this works. Anywhere along this line represents an equilibrium, all right? A back and forth between being a liquid and a vapor. So if I increase the temperature on something that's in the liquid phase, I can bring it over the line, over into the vapor phase, and that's a phase change. I go from a liquid to a vapor. If I increase the pressure on something that's in the vapor phase, I can eventually get it to go over the line and get it to go into the liquid phase. So anywhere along that blue line represents the point where you're turning from a liquid to a vapor or turning from a vapor to a liquid. So if we include solid in this, we end up with all three phases being represented. So at this particular temperature, 0.01 degrees Celsius and 0.006 atmospheres, I'm at what's called the triple point. I'm at the equilibrium between being a solid, liquid, and a gas all at one point. All right, so at this point, you're not any of these, right? You're at the cusp of being either one of them. Critical point is a position where if I increase the temperature to a certain extent, there's nothing I can do to the pressure to bring it back over into the liquid phase. So critical point is the pressure and the corresponding critical temperature at which a gas and a liquid are in equilibrium, but if I increase the temperature past that point, there's nothing I can do to bring a substance back over the liquid phase. So looking at this, right? Normal, right? Normal is 1 atmosphere pressure. So 1 atmosphere pressure, we have the freezing point of water, right? 1 atmosphere pressure, right, at 0 degrees Celsius, right? That the cusp between being a solid and a liquid at that point along the red line. If I increase the temperature, eventually I get to 100 degrees Celsius at 1 atmosphere of pressure, and I'm at the point of boiling, right? Like the cusp between being a gas and a liquid. So if I increase the temperature past 100 degrees Celsius, I'm in the gas phase. If I increase the pressure above 1 atmosphere pressure, I'm in the liquid phase. So this is how you look at this diagram. Now, notice, I keep flicking back and forth. Water is the only one that does this. Water is the only one where the liquid phase bends back into the solid phase as you increase the pressure on it. This is how, well, the fact is water is the only thing where the most dense phase of matter is in the liquid phase, not the solid phase. So ice floats on water, right? Water doesn't float on ice. So as you increase the pressure on a particular piece of ice, eventually go into liquid phase, right? So this is the whole basis behind ice skating. If I put pressure on it and drive it over the line, I have a liquid underneath my skate, and that's where I'm able to slide around on ice. If I do the same thing with any other substance, right, this is carbon dioxide, as I increase the pressure on it, I drive it more into the solid phase, right? The solid phase bends in the liquid zone. So increasing the pressure on it drives it more into the solid phase. So no, you can't ice skate on dry ice. You can only ice skate on water, on ice. So 1 atmosphere of pressure at minus 78 degrees Celsius, carbon dioxide goes directly from the solid phase to the gas phase, right? This is called sublimation. So anywhere along this line between the solid phase and the gas phase is the sublimation point. As I increase the pressure, eventually I get to the triple point of CO2. All right, so at 5.2 atmospheres, minus 57 degrees Celsius, this is where I start to liquefy CO2. So you can get liquid carbon dioxide, you just have to get the pressure high enough. So sublimation going in one direction, deposition going in the other direction. I was trying to search for the name as I was looking back before. Again, solid zone, everything packed together, right? The only motion you're allowed is a vibration. In the liquid zone, you're allowed a sliding motion past each other. So anywhere along the blue line, we have melting point or freezing point. I always ask people, what's the freezing point of water? Right, 0 degrees Celsius. What's the melting point of water? 0 degrees Celsius. So 1 atmosphere pressure and 0 degrees Celsius, you're at the cusp between melting and freezing. Vaporization, condensation, right? Anywhere along the red line, you're condensing or you're vaporizing. The liquid vapor interface starts at the triple point, right? So at all, right, T, at which all three states are in equilibrium. So we're going back and forth between being a liquid, a solid, and a gas at the triple point. Each point along this line, right, is the boiling point of a particular substance at that pressure. Right, so increase the pressure, increase the boiling point. So below the triple point, a substance cannot exist in the liquid state, right? So we're subliming or we're deposing, going along the green line.